Hello, this is Evrada, and this is a show and tell of my Rube Goldberg device. So for an overview, this is the device. It starts from here, continues here, there, here, the ball, this, and ends there. So for a start, I will trigger this by dropping a ball on this, anywhere on this course, such that it can roll and end up in this on the seesaw, on this side of the seesaw. Now the seesaw is currently balanced, as we can see, but dropping the ball in here is going to change the moment on this side, such that this will topple, this will fall, and this will rise, causing this spring to be pulled from under these dominoes, which will unleash the chain of dominoes falling, ultimately toppling these little dominoes building, which will release this pendulum. The pendulum has some dominoes in it as well to make it heavy, such that when it swings, it can hit this ball and actually make the ball fall. Now the ball in its path, and with the help of these strings, which helps as a kind of, I think the plastic on plastic attracts each other for some reason, so it follows the course better with that on. So fall straight into this cup, which, because of the presence of these elastic strings, will be pulled down, and with the force with which the ball is falling, it's going to hit this pile of books, and the pile of books acts as a makeshift spring with a high spring constant. So since there is air between the pages and air between the books, when this ball and cups fall at high speed, they cause the books to slightly compress, very slightly, but enough to cause this box with 4 styla attached to it to be released from this break. So basically, when it presses slightly, it causes this, which is directly leaning on it, to also fall slightly, releasing this from its break. So the break is just rubber bands that prevent it from slipping. Because it is smooth, I also added tape under it to make it even smoother, and the book itself is also very smooth. So it ultimately rolls down once released from its break, rolls down following its course. We have some rubber bands at the sides too to make it have a straight course, and we have some boxes here with rubber bands as well. They are made wide such that it has more than enough space, because I noticed that when they are too close and this box hits them, it reduces in speed, which makes sense because it is hitting them and transferring some of the momentum to them. So the path is wide enough such that it has free way without hitting any of them, so it can fall down at high enough speed to hit directly on the shutter button on the phone. That is the contraption. That's an overview of the device. Now for each individual step and the law of conservation of energy and momentum, what happens with the ball here is it is dropped from a height h above we'll call the origin the ground, because we're starting my device from the ground. So because of that, it is losing in height. So as it is losing in height, because energy has to be conserved, the some of its potential energy is gradually getting converted into kinetic energy, such that it picks up speed as it descends. And once it descends into this little basket, it has before falling, before touching it, it has a moment of mv. That's its mass times its speed. But because it is going to fall on this, which was previously stationary, causing the whole thing to move, it has to, we'll call it share some of its speed with all of this, such that moment has to be conserved. So if calculations were made to determine the speed of the ball once it touches this is probably going to be lower. It's most definitely actually going to be lower than when it was falling on its own. So with that, the moment is conserved, and the seesaw also moves on the because of the influence of the speed of the initial ball, and it picks up some speed as this falls down, as this gets lower too. And as this one gets higher, the string is pulled from under the dominoes, which unleashes this chain of reaction here. Now the dominoes, the string, I guess it's tension because it's not elastic. So the force exerted on underneath the dominoes really will be tension, causing them to be unstable because they are in an orientation where their center of gravity is too far from the base they are seated on, so they are relatively unstable. So that low tension is going to cause them to topple and fall flat, such that the center of gravity can be closer to the floor or to the surface they're resting on. That is more stable for them. So as it topples and causes a chain of reaction, I made them into 2 courses just to hopefully make sure this falls, even if one of them fail. So as that happens, as the dominoes fall, since they are in such a position where their center of gravity is further away from the ground, they have stored potential energy, because potential energy is as a result of center of gravity being away from the ground. So they have potential energy stored. So as they are falling, the potential energy is being converted into kinetic energy, causing them to have speed when falling, causing them to fall with a certain speed. So the same thing happens to each dominoes, including these ones, which have an even higher potential energy because of their higher distance from our origin. And as they fall, they release this pendulum thing, which similarly is also high up. Therefore, as it falls ultimately from the toppling of the dominoes tower, its stored potential energy is also converted into kinetic energy, permitting it to move front and back and front and back. And for the first time it moves front, it hits this wall. And from previous attempts, I noticed that if it did not have enough weight, it will just touch it and not do much. So I had to stack up some dominoes in there as well to make it heavy enough to actually push this and cause it to topple and fall. So this ball will be pushed by that. Of course, there's also the conservation of momentum in each of these steps. So as this falls and hits this, it transmits some of the momentum to this, such that the ball can move forward with a certain speed, and this one can move backward with a certain speed as well, ensuring that momentum is conserved in the whole interaction. Once the ball rolls forward first, and then ultimately downwards once it crosses the end of the table, it falls into this. This is connected to a spring and it is suspended. So in this state, it has first of all stored elastic potential energy and potential energy from its height as well, due to its height from the origin. So once a ball falls into the bucket swing thing, it causes the spring to extend further, which causes a buildup of more buildup, that is, of elastic potential energy, as its potential energy from the height, due to the height, is decreasing. So as it falls and this is getting lower, the potential energy due to its height from the origin is decreasing, while the elastic potential energy is increasing because the string is increasing, and as it moves with a certain speed, it also has kinetic energy. So the conversions happening here will be potential energy being converted into elastic potential energy and kinetic energy. Once it falls on this with, almost fell, my bad, with a high enough speed because of the weights and the fact that it's falling with acceleration, which means it falls with a certain force as well. So it falls on this, which, like I said before, is a kind of makeshift spring with a high spring constant. So as it falls on this, it will cause it to compress slightly as well, which means some of its potential energy, due to its height, is going to be converted into elastic potential energy. As it is compressed, that's the height is reducing, so there's a decrease in the potential energy due to the height and an increase in the elastic potential energy. So that is going to, well, once this bounces on it first time and it comes back up, because this is elastic, so it's going to be dragged back up, this will do the same, and these which are on this will automatically follow as well because they rest on it. So as they are following, this one, which is really held just by this elastic spring which acts as a brake, moves down under the influence of gravity, under the influence of its weight, accelerating on our angled course and ultimately hitting, I hit the books, my bad, ultimately hitting the shutter button. So this as well, the conversion of energy happening here is conversion of its potential energy into kinetic energy as it is descending and losing in height from our origin, which we determine to be the ground. And that marks the end of our course and the explanation of the workings of the Rube Goldberg project. I believe it has 8 steps. Yes, thank you.